think there are probably two things that influenced me towards chemistry. One of them was the Gilbert chemistry sets, and this was back when the sets had real experiments, had real chemicals, things that probably were even a little dangerous and things that are no longer put in the chemistry sets. But they were fun. And the other thing that it really intrigued me, like a lot of kids, were fireflies. I grew up in northern Indiana, lots of fireflies. We would catch them, of course, and then let them go, but it was always intrigued me how the firefly generated its luminescence. Years ago, we found out how that was done, but that's sort of several years after into our research. But then, once I got into high school and started taking science classes, I was particularly intrigued with chemistry, and I think stimulated by a fantastic high school chemistry teacher, Clyde Mott. Sort of short in stature, always wore a white lab coat, and developed experiments that were outside the textbook. You might even try to call them research experiments, but something different, something unique. And that really intrigued me, and I really give him credit for stimulating my interest and eventually getting into chemistry as a career. Well, you weren't doing something that was rote, something that you knew what the outcome was going to be, because it was all written there and you knew it had been tested and you knew what the result was. The experiments that he developed where we didn't know the outcome just seemed to me so much more interesting and exciting. Well, I'll start back at Hope College, which my dad went to Hope. It's fair to say he never took a science class. He became a Presbyterian minister. But he appreciated my love of chemistry, and as it turns out, Hope College then, and this was in the mid-60s, and still today has a fantastic chemistry department and has a history of undergraduate research. It's recognized nationally for the quality of its undergraduate research. So I spent 3 years with Professor Douglas Neckers in his laboratory doing undergraduate research. It led to refereed publications. It was, I must say, unbelievably exciting for the first time to see our results in publications, in national publications. He had a huge influence on my career, and I'll describe perhaps in several ways. One, at the end of my Hope career, my last semester, he arranged for me to go to the University of Groningen in the Netherlands and spend 6 months doing research with Professor Winberg, Hans Winberg. That was, again, a fabulous experience, all devoted to research. And then he was instrumental, Dr. Neckers, in getting me directed toward Harvard. He had been a postdoc there, and so he knew Harvard very well, and in particular knew Professor Paul Bartlett. And Dr. Neckers said, if you can get into Harvard, this is who you have to work for. And he was absolutely right. I had a wonderful experience with Professor Bartlett. And that was my career at Harvard with Dr. Bartlett, was where I first got involved with these compounds called 1,2-dioxetanes that generate luminescence and really are believed to be the intermediate responsible for the luminescence of fireflies. And as part of my research with him, I was able to make one of these dioxetanes for the first time. It didn't generate much luminescence, but it did some, and it was very unstable, almost to the point of being explosive, but it was the beginning of this whole area of research. And then as I was finishing my PhD, Dr. Neckers again was important in a way that I didn't know about at the time, but I was looking for an academic position at a university, and Dr. Neckers knew Carl Johnson here on the faculty very well. and said to Carl, you ought to interview and take a look at this young man, Schaap. And in fact, that happened. I came here and gave a lecture and interviewed and was offered a position as an assistant professor. That was in 1970. But that was Dr. Neckers working behind the scenes to at least help open the door for me. And we talk about pivotal moments, and I would call the time that I accepted that offer to come here as certainly one of the pivotal moments related to Wayne State University for me. When I was interviewing, there were, I believe, 3 universities in the whole country, only 3, that had positions for organic faculty, organic chemistry faculty. One was at Wayne. I interviewed at the other 2. And before I heard anything about the other 2, I accepted this position. And it's strictly because of the quality of the faculty who were here, the faculty who would become my colleagues. I just recognized there was something special about the culture of this department. And it turned out to be absolutely right. Professor Calvin Stevens was the chairman, and I call him Cal. Cal is now 92, I believe. He was a real mover. He had been building the department, getting other faculty, really high quality faculty, to come to Wayne State. Norman LaBelle, Professor LaBelle, now deceased, was one of the senior faculty, again, a very good colleague. But in particular, let me mention Carl Johnson. Carl was the head of the organic division in this department, and Carl became my mentor. It's fair to say, a fairly green, young organic professor, assistant professor. I did not do a postdoc, so I came directly from graduate school to here. And Carl, as I mentioned, was my mentor, helped me in a lot of ways in writing papers and submitting grants, and just taught me, and became a lifelong friend. Well, the atmosphere in this department was very exciting, very stimulating. The chemistry building that we're sitting in had just been finished in 1969. So it was a brand new chemistry building, brand new laboratory, state of the art. They were recruiting top quality faculty, building the department. The department had just been awarded a Center of Excellence grant from the National Science Foundation. So it was a very exciting, stimulating time to come to chemistry at Wayne State. Well, I retired in 2000 from this department to become full-time with Lumigen, the company that I had started. And it's fair to say that in the 30 years that was from 1970 when I started to when I retired, this building, the laboratories in particular, had really begun to show their age. They were certainly no longer state-of-the-art. They were, in some cases, not even safe anymore. And so to go from, and the outside was really looking pretty tired too, but most importantly, the laboratories were no longer adequate. And it became, I think, difficult to attract students, difficult to retain faculty members. And so this building was in need of total renovation, which of course was a very expensive proposition, but it needed to be done. Now we're sitting in a chemistry building that is in fact fully renovated, all the laboratories. They are now state of the art again. And in addition, we have some other spaces that we didn't have years ago. The atrium, which is a 4-story glass atrium that is a wonderful interaction area. We have our own dedicated lecture hall, which was a problem too. The lecture halls of Science Hall were in pretty sad shape, to the point of being embarrassing when you would invite an outside speaker. That's certainly not the case anymore. The lecture hall is just beautiful. And within the building, there are some elements that are also new and very important. These are interaction areas. Each floor has a special area that's now set aside. It's got windows that is dedicated to the interaction of faculty and students, postdocs from different groups, so that they can come together, talk about science, because now this is the way modern science occurs. It's no longer just stay in your own laboratory, be in what's called a silo, but scientists are urged to collaborate, to interact, to develop joint programs. And in fact, the laboratories now sort of reflect that thinking. The laboratories are now open. Groups, different groups, share laboratories, all to foster collaboration and interaction. I mentioned that at my graduate work at Harvard with Professor Bartlett involved making one of these molecules, a dioxetane. A dioxetane is a 4-membered ring that has 2 oxygen atoms, 2 carbon atoms, and of course some other things attached to it, but the heart of the molecule is this 4-membered ring, and that's where the energy is. And as a chemist or a photochemist, we make these molecules, we put the energy in. That area of research, with Dr. Bartlett's permission, I brought to Wayne State, and it became the focus of my academic career here. And over the course of 16 years, collaborating with undergraduate students and graduate students and postdocs, and we worked together to make many of these molecules, these dioxetanes, study their properties. Some of them turned out to be a little more stable, some a little more luminescence, but none of the molecules had all the properties that we desired. And I must say, I need to give credit to those collaborators, to the students, the postdocs, the undergraduates, because science is a team effort, and we wouldn't have made the progress we did. I certainly wouldn't have, without the high quality collaborators that I did have. But after 16 years of not a straight path to the end result, science is always kind of a jagged path of going off in the wrong direction, we were able to make the molecule that had all the properties that we wanted. And perhaps if I can show you that demonstration. And this, what I'll show you really, and this occurred in July 1986 in the laboratory just a few feet from us, really was the pivotal moment in my career here, because it became the underlying technology that led to the products and the formation of our company of Lumigen. So again, I'll pour this into here. That destabilizes the material, the dioxetane, which then spontaneously decomposes. And I'll just do that a moment. Let me put this top on, give it a shake. That's now decomposing to generate luminescence with an efficiency of about 50%. And this became the underlying technology for our company. That kind of efficiency, the ability to trigger the luminescence, and then after a few months more research, we were able to make other derivatives of this, one in particular that became useful in medical diagnostics, and that was the foundation of the company. So with additional derivatives of the material that I demonstrated, particularly one that was a phosphate that could be triggered by the enzyme called alkaline phosphatase, that became useful in medical diagnostic tests that used that enzyme as a label. These are tests that already had existed in medical diagnostics, but they used other methods of detection, compounds that would turn color, compounds that gave fluorescence. But the material that was developed with the phosphate group was in fact thousands of times more sensitive. It was non-toxic, certainly not radioactive as some of the tests were at that time. And companies that had those tests began to get in touch with us asking for samples that they could use to test and see if it improved their assays. And in fact it did. And they then said, well, let's find a way to obtain commercial quantities of your material. And that led me to form the company, Lumigen Incorporated, and then to approach the university about collaborating with us. In other words, becoming a part of the technology transfer, part of the startup of the company. And the university then licensed, because the university owned the technology that we had worked on, but licensed the technology back to our company, and in fact Wayne State became one of the key shareholders at the start of the company. And they were kind enough to lease some of my laboratory space to me so that we could incubate the company in this building. That was before the days of Tech Town, and there just was no laboratory space anywhere for us to start the company. It was a very, very satisfying relationship. And they also were willing to take a chance on a faculty member, myself, who had no business experience, and to give me and my colleagues a chance to commercialize the technology. And for that, I remain extremely grateful. If it weren't for the support of then Dr. David Adamany, the president of Wayne State, and the Board of Governors, Lumigen would not exist today. Lumigen is in Southfield in its own building, making commercial materials, luminescent materials for assays and tests that go around the world. The key first members of the company were former graduate students of mine. And in fact, the CEO, the director of Lumigen now, is a former PhD of mine who was with my group in 1986 when all of this transpired. So he has now been almost 30 years at Lumigen and is in fact in charge of the company. Well, as I mentioned, Lumigen would not have existed but for the unbelievable support of Wayne State. The administration, my colleagues here, of course, the graduate students became the foundation of the company. So it's a company that owes its existence to this university. So I think it's appropriate for Carol and I to give back to the university, and in this department in particular, because of the support that we received when we were starting out. The atrium and the lecture hall, and I think when Carol and I, in fact I know, when Carol and I made the offer to fund these additions to the chemistry building to make it really something special, that was the carrot that stimulated the administration, then President Reed and the Board of Governors, to bond the funds necessary to finish the renovation of the interior of the chemistry building. So it was a good partnership to get this all done. That was formerly called the Central Instrument Center. It's a group of laboratories in the basement of the chemistry building that house major instruments that are used by various faculty members. They are very expensive instruments. They're, again, used by multiple investigators. Investigators also outside this university, other universities in this area, and also companies have access. And there are nuclear magnetic resonance spectrometers, there's mass spec, there's X-ray diffractometers. I think I've heard the number of something like $25 million worth of major instrumentation housed there. However, when this renovation was being finished, the one area of the building that was not going to be renovated was that instrument facility. And so Carol and I said to the department administration and to the university, if we chip in, perhaps you can find the funds to finish the renovation, and that's what they did. And that led to its renaming as the Lumigen Instrument Center. It's now a world-class facility. Find something at the university that you're passionate about. For me, it's chemistry, it's science, it's students. But for someone else, it might be engineering, it might be business, it might be dance, it might be medicine. But find something that you're excited about, you're passionate about, and then find a way to make a difference. Whether it's to improve facilities, to set up scholarships, to set up endowed chairs. There's lots of ways to help and lots of ways to take sort of what you're interested in to the next level. But make sure you start off by finding something that you're passionate about, that you're excited about. Well, Wayne State, of course, has been ever since it started in the middle of Detroit. So it is linked to the city, and it's fair to say that the city has benefited from the presence of Wayne State in its midst. I believe it's the intellectual center of the city of Detroit. It is an unbelievably important economic engine for the city of Detroit. On the same hand, the city of Detroit has a huge impact on the quality of the existence, if you will, of the university. The two institutions, if you will, the city and the university, are linked. And so it's important that the Wayne State do whatever it can to help the city of Detroit. And when the bankruptcy began and they started talking about having to sell pieces of art from the DIA, Carol and I just thought that this would be an absolute tragedy. It just would destroy the morale of the city if they had to sell even one piece of art. And so when Judge Rosen was talking about the grand bargain, which was to try and raise funds from major foundations for two purposes. One, to minimize the hurt to the pensioners, but also to provide support for the DIA and, if you will, to shield the DIA from having to sell or the city having to sell the DIA treasures. And so when we saw that, I said to Carol that I think this is going to be a tough sell to get these outside foundations to contribute. And so that led us to make our offer to sort of jumpstart the grand bargain. That is correct. Carol was the secretary to the chairman when I applied to Wayne, and then later accepted the offer. And so Carol and I met here at Wayne State. That was a pivotal moment as well. Oh, I think it's fair to say this facility, because it's clear that this facility, the quality of what we have here now, is helping to recruit faculty, to retain faculty, helping to recruit graduate students and postdocs. You need to have the underlying quality of the research and teaching program, of course, but you also need to have good facilities, and I think this provides it. That's an easy one. It's scholarships. I would not have been able to go to Hope College but for scholarships. As I mentioned, my dad was a Presbyterian minister. Goes without saying, they don't make much money. And so to go to college was possible only because of scholarships from Hope College and from people I never met. The same thing was true going to Harvard, going to graduate school. Their support from the National Science Foundation, support from the Woodrow Wilson Foundation. Again, scholarships. And so that's kind of behind the philanthropy, at the heart of the philanthropy that Carol and I do, and that's scholarships to students at all levels, at grade school, here at Wayne State, at Hope College. It's trying to give back in a way that helped me. I mentioned the scholarships to students at the charter school. This is K to 8, and we provide scholarships to students. This is an intercity charter school. Scholarships to students who have graduated or are graduating from the 8th grade, and it allows them to go on to really high quality high schools. University Liggett, Regina, University of Detroit, Jesuit, De La Salle, and some of these students are now graduating from these high schools and going on to college. And I met a brother and a sister who are both now at Kalamazoo College and doing extremely well. They came back to say thank you. That's the end result that you want to see. Oh, I think it's pretty clear. The ability to help the university in building this facility, in this atrium, the lecture hall, and then stimulate the renovation of the inside of the chemistry building and the laboratories. Putting that all together was a really high point for me. I mentioned the culture of the chemistry department. That was important in my decision to come here. And in particular was the culture of the organic division, because I'm an organic chemist, and the people, the faculty who were there at that time. And they had a wonderful, warm relationship in that division. And just a welcoming, supportive environment. And You don't find that all the time amongst any institution, but it was special here, and it remains special.
I think that also plays into what you were saying about chemistry now. It's about collaboration.
Correct.
It's about working together.
Correct.
Kind of ahead of the curve on
Yeah.
that.
What you don't want to find yourself in is with a group of prima donnas that have no interest in interaction and collaborations, and that wasn't the case at Wayne State and is certainly not the case now. It's just a special environment here. And I recognize that even as back in the 70s as an assistant professor. I'm a little hesitant because each generation of graduate students, each group of graduate students would often have sort of a particular student that was kind of the leader. But I think of one person in particular. His name is Dr. Richard Handley. And Rich was an undergraduate student with me for 2 or 3 years, then stayed on to do it's not the norm for an undergraduate to stay at the same institution. He stayed on, though, here and obtained his PhD with me. And then also, when I started the company, he became one of the founding employees of the company. He just retired a few months ago, but when he retired, he was head of intellectual property, not just for Lumigen, but for now the parent company, Beckman Coulter, as well. So he transitioned from an undergraduate to a graduate to a very skilled patent agent, and he is just a wonderful scientist and very skilled in lots of ways. His PhD dissertation was fantastic. I did nothing more than wave my hand at it.